So today's topic is about momentum, how we define the term momentum and why it is important for us to study the momentum. Example, if I say I have two objects of different masses, one is 2 kilogram, another one is 10 kilogram. Both hit the wall. Which one will have a greater impact when it hits the wall? Is it a 10 kg or a 2 kg? Which object will have a greater impact when it collide or hit the wall? 10 kg. Like most of the student answer 10 kg. But what if I say that 2 kg was moving at a speed of 100 meter per second and 10 kg is only moving at a speed of 1 meter per second. Now, which one will have a greater impact? So now the 2 kg is having a greater impact. So what actually you did not consider the mass, or you not only consider speed. Whenever we consider an impact during a collision, we consider the mass and the velocity. So mass is 2 and the velocity is 100. So it will have 2 kilogram meter per second, the momentum. But what about the 10 kg? The mass is 10 and the speed is 1. So the momentum is 10 kilogram meter per second. So why the momentum is important for us? Why the physical quantity momentum is important? That using the momentum, we can predict how the object will behave when they collide with each other, or which object will have a greater impact when it hit the other one or hit the surface. So to understand the concept of the impact during a collision or when the things collide, we use the physical quantity momentum. So momentum is actually a product of mass and velocity. And momentum is a vector quantity. So the direction of the velocity is same as the direction of momentum. So whenever you study impacts, you always consider the momentum of the objects. So it's denoted by letter P, where M is the mass and V is the speed. If an object is there of mass 2 kilogram, moving at a velocity of 10 meter per second, and suddenly changes the direction, but the speed remains the same, is there a change in momentum? Is there a change in the momentum? Yes or no? Is the momentum changing here? So the correct answer is yes, there is a change in momentum. But why there is a change in momentum? Because momentum is a vector quantity. So not only the magnitude, change in the magnitude changes the momentum, the change in direction also changes the momentum. And whenever the momentum change, what we call another quantity, and we call that as impulse. So impulse is actually a change in momentum. And if I want to calculate the impulse here, say the momentum was 20 kilogram meter per second at the beginning, okay? And the momentum is also 20 kilogram meter per second, but the direction has changed. The unit of the momentum is kilogram meter per second. I want to calculate the impulse. Impulse means the change in the momentum, or we can also say the final minus initial. In terms of the vector, how we do, like this was an initial momentum and this is a final momentum. In terms of the vector, if I need final minus initial, so what I will do, I will draw the final vector first, because I need final minus initial. So I do the final vector first. This is a final vector, okay? The final momentum. Then I have to draw negative initial. If initial was towards right, what is the negative initial? Towards left. So I will draw a negative initial according to the magnitude. So I will draw a negative one. towards the left-hand side. What about the impulse here? Impulse, it's a vector again. So when we join from tail of the first to the head of the last, that will be the impulse, which is the change in momentum. Is it clear in terms of the vectors? What is impulse? Impulse is the final momentum minus initial momentum. So first we do a final vector, then we do initial vector, but in opposite direction, and we took a difference. Whenever you take a difference, initial will be negative, yes. So whenever you want the impulse from the vector, if they give you the initial vector and the final vector and they ask what is the impulse, so you have to draw the final vector first, then opposite of the initial, and from tail of the first to the head of the last will give us the resultant. So what is actually impulse? Impulse is a change in the momentum, mv minus mu. Now, how we can relate the impulse and the force? So according to Newton's second law, F is equals to ma. Force is mass multiplied by acceleration. I did not understand the vector. Okay. Look, I will explain again the vector diagram. Example, an object was having a momentum, the starting momentum of 2 kilogram meter per second. Okay. And it has a final momentum in this direction, which is also 20 kilogram meter per second. This is a starting momentum, the initial, and this one is the final momentum. How we define the impulse? The term impulse means the change in the momentum. Or we can also say the final momentum minus the initial momentum. So when the final momentum subtracted from the initial momentum, we get impulse because the difference, the change. In vector, how you work out the change? Like if I say, find the resultant of A minus B. So first we draw A, then we draw opposite B, and from tail of the first to the head of the last, that will be the resultant. Same thing here. We draw the initial vector. The final vector, because it's final minus initial. So we do the final vector first. Now we need negative initial. If initial was toward the right hand side, what will the direction of the negative of initial? It will be opposite. So it will be towards left hand side. That is a negative of initial. How to find the resultant? When we join from tail of the first to the head of the last, what we called resultant. And in this case, the resultant is a impulse, which is the change in momentum or final minus initial. Is it clear? The vector diagram of the impulse? Now, how we can relate the Newton's second law? How we can relate the Newton's second law with the impulse? According to Newton's second law, resultant force should be equals to ma. Whenever the object accelerate or decelerate, the resultant force is always ma. What is acceleration? Acceleration is a change in the velocity. So we can write, in place of acceleration, we can write v minus u over t. So this will be f m multiplied by v minus m multiplied by u. And then whole is divided by t. What is mv minus mu? That is a change in the momentum, or we can also say impulse. Because the final momentum minus initial momentum, what we call impulse. So I can say F is equals to impulse divided by time. If I need the impulse, so time is divided, other side multiplied, so force multiplied by time. is equals to impulse. So that's why when we write the unit of the impulse, the unit of the force is Newton and unit of the time is second. So we say the unit of the impulse is Newton's second. That's a unit of the impulse. Is it clear, the concept of impulse? Any doubt in this? So according to Newton's second law, whenever there's a resultant force, it's always ma, and acceleration is the change in velocity divided by time. When we multiply both sides by m, we got mv minus mu, which is an impulse. So impulse is force multiplied by time. So there are two formulas for the impulse. If you need the impulse or the change in momentum, either you can use mv minus mu, or you can also use force multiplied by time. Any question or doubt till this point about the concept of impulse? For example, if I sketch a graph between a force and time. So there's a graph between the force acting on the object and the time interval for which it is acting. It can be a straight line or a non-linear. If I take the gradient of this graph, so gradient means the quantity on y-axis divided by quantity on x-axis. That's the gradient. So if I take the gradient of this graph, it will be force divided by time. But if I take area of this graph, area of any graph is a quantity on x-axis multiplied by quantity on y-axis. Or quantity on y-axis, order can be changed, it does not make difference. Quantity on y-axis multiplied by quantity on x-axis. So what I have force on y-axis and I have time on x-axis. So what will happen? If I take the area of this graph, what I will get? I will get force into time. And what is force into time? Force multiplied by time. What is this quantity? That is known as impulse. So if I have a graph between the force and time and I need an impulse, so how I can work out the impulse? I can simply take area under the graph. So when I take area under the graph, what I will get? I will get an impulse. Is it clear? Any doubt in this? The concept of impulse and how we can calculate from the graph? Any question or doubt till this point? So always remember the area of the graph is the quantity on y-axis multiplied by x-axis. And the gradient of the graph is the y-axis divided by x-axis. Area of a graph is equals to impulse. Yes, that's right. If f and t were indirectly proportional, so why does the graph shows? Yeah, a very good question, Asha. That look, we wrote a formula that f is equals to impulse, like f into t is equals to impulse. Okay. If the impulse is constant, in that case, f is inversely proportional to t. In that case, the graph between the force and the time will be like this. But what is happening in this question? In this question, the impulse was not constant. Impulse was continuously changing. The graph which I sketch here, the impulse is not constant. Here, if we apply a greater force and we apply for a longer period of a time, so the value of the impulse will increase. So means the area will increase. That's why when we are increasing a force and the time, the area was increasing. So that's why the graph area was increasing. That's why the shape of the graph was like this. If the impulse was constant, then what should be the shape of the graph? It should be like this. But usually what happened, if I apply a greater force, or I apply a force for a longer period of a time, the impulse will increase. So the impulse is not constant. Is it clear? The shape of the graph. So if the impulse was constant, then the graph will be different. The second graph will be given if you have different objects, you're performing an experiment, and the impulse of all the experiments were constant. In that case, you will have a graph curve like this, which shows if you have a high force, then the time should be shorter. If you have a lower force, then it will act for a longer time to produce the same impulse. So momentum, these are the learning objectives. The momentum, which is a product of mass and velocity, and it's a vector quantity. And we just discussed how the force and momentum are related to each other. There's a word example. A force acting on a body of mass 2 kg causes speed to increase from 2 meters per second to 6 meters per second. Find the average force acting given that it acts for 2 seconds. If the final velocity of the body is in the same direction and in opposite direction. So first we work out the initial momentum, 2 multiplied by 2, 4. And we work out the final momentum, 2 multiplied by 6, which is 12. So what is the change? If we need the average force, so the force will be impulse divided by time. So impulse is the final minus initial. So 12 minus 4, which is 8, and 8 divided by 2, we get 4 newtons. But what if the direction is opposite, like direction has changed? The object first, it was moving at 2 meters per second, and then it changes the direction opposite 6 meters per second. So when the direction change in physics, like how we represent a change in direction, opposite direction, we take one as positive, the other one will be negative. So if I take right hand side as positive, the left hand side will be negative. What is the momentum? The mass remained the same, 2 kg. So what is the momentum here? 4 kg meter per second. What is the momentum here? Minus 12 kg meter per second. What is the impulse? The change in the momentum. So the final, which is negative 12, minus the initial is 4. So this will be minus 16, the impulse. And we need the force. So force is impulse divided by time. So impulse is negative 16 and the time is 4. So the change in the force which is acting is negative 8. What is the negative 8 is representing? Negative 8 represent that the force is opposite to the direction of the motion. Like if an object is moving towards right, the force is in opposite direction. Is it clear? The two examples of the momentum and impulse, how it is calculated when there's no change in direction and there's a change in direction. Any doubt in this? What if we have a non-linear graph is there? What if we have a non-linear graph? In a non-linear graph, the area under the graph will also give us the impulse. So in the graph, the shaded area is an impulse exerted between A and B. If we need the total impulse, it depends on the question. If we need the total impulse, we'll take the total area under the graph. But if we need the impulse from position A to position B, so we will only take area of that part. And for a non-linear graph, we'll use the same method, like we divide the graph into segments, the horizontal and the vertical equal segment. And find the area of each segment, multiply by the number of the segment, we'll get the total area. But it will be approximate answer, not exact answer. And according to principle of conservation of the momentum, the total momentum before is equals to total momentum after. So whenever an object explode or object collide in an isolated system, when we use the term isolated system, it means there are no external force acting on the object. Like frictional force is neglected. As you can see here, as this, in case of it explode, the firecracker, so why you see a symmetry in the explosion? Because what is the initial momentum? The initial momentum is zero. The starting momentum is zero before the explosion. So if the starting momentum is zero, the final momentum should also be zero. That's why if one of the fragment is moving towards right, the other fragment will move towards left. If one of the fragment is moving upward, the other fragment will move downward. If one of the fragment is moving diagonal, the other will also move diagonal. So whenever explosion happen or occur, it always follow the symmetry to conserve the momentum. Same thing